Part C.2, partitioning in Quicksort. This is the most important step. So we will spend a lot of time to study the details. All right, so here we know the property we want to make. This is the key property. Okay? Any element in A subarray must be less than any element in B subarray. In other words, that is, the maximum of the A element must be smaller or equal to the minimum of the B subarray. Okay? Yeah. So different way, but the same thing. Okay. But how do we get that? Okay. So let's look at the implementation of this device step. Yeah. All right. So let's work on the implementation details. So when we start, we have a general array, like this. All right. How to split? Okay. So when we do the splitting two subarrays, we keep in mind we want this property. Okay, yeah, in our mind. All right. But how to get that at this point? Yeah, we do not have any idea. Yeah, so we want to explore some key property here. Yeah. So here there is an uncertainty regarding the size of A subarray and a B subarray. Nobody knows that. How many elements in A subarray? How many elements in B subarray? Nobody knows that, right? For the merge sort, when we do the splitting, we pretty much know the size of each subarray, right? Approximately 1/2 of the whole array. Okay, but for our new idea, new view, we have no idea on that. Anything could happen. Yeah, anything could happen. Yeah. So, but how to resolve that uncertainty, right? How to make it certain? It's not trivial. We need to do a lot of things to get that. Yeah. To be more specific, we need some special element to separate two subarray. The subarray, later we need to join those two subarray, right? Think about the point that we join two subarrays, the boundary, the edge point, the join point. Think about that special element. Okay? Yeah. So that special element has a key property. Try to imagine what key property it must have. Very simple, in place. That special element must be in place. You know the meaning of in place, right? Yeah, you know it. Yeah. That element must be in place, in the right position after the whole array sorted. That special separation element between two subarrays. So we try to locate that special element. If we can find that, we make it. We resolve that uncertainty. Okay? Yeah. All right. So determine boundary of two subarrays. We need to do this. Okay? All right. From this diagram, we look at a special element somewhere in the middle. P, we call it pivot element. Pivot. Okay? Yeah. It's critical. Pivot. Yeah. Pivot element. And this pivot element must be in place. Okay? Yeah. As required, must be in place. Yeah. How? That's another issue. We try to answer that question. How to find that pivot element in place. Later you will see there is a very smart idea to get that. Yeah, we delay. How to make it? We delay that. Yeah. But we know with respect to this pivot element, all elements in subarray A must be less than or equal to P, and all elements in B subarray must be greater than or equal to P. If we have this property, you can see we automatically have the required condition for our divide step. See? Yeah. So we get a little more information here. Yeah. So let's keep working to get more information. Yeah. Which element is used as the pivot? You need to find that pivot element, right? Yeah. It is not trivial. You have to do a lot of work to find that pivot element. Okay. First, observation. Any element has an equal role in the array. So what do you mean equal role? Can you say which element has larger chance to be the pivot? Can you tell me, given an arbitrary array, can you tell me which element has larger chance than other elements to be the pivot? Nobody can tell me that, right? All the elements have the equal chance. So that's why here I say equal role. Okay? You cannot favor anyone, right? You cannot favor any element than other elements. Okay? Yeah. So no reason to favor any particular element. So that means you have freedom to pick arbitrary element as the pivot. You have that freedom. Okay? So, yeah. So that's another observation. Yeah. So then we can say the pivot element, just a random selection. Which one to be used as the pivot? Random selection. Okay. Yeah. Then, now, when we go another level deeper, yeah, position-wise, then, yeah. So here, when we talk about the random selection, equal row, all those things, we are talking about values, right? Values of the elements. When we talk about values of the elements, then we cannot favor anyone. Yeah. But other than value, there is another aspect that is important for this problem. That is the position aspect. Position aspect. Yeah. The elements in the array, they have different positions, right? From the first one to the last one. The position, quite different. Yeah. So the position-wise, element at which position is the most convenient to be used as the pivot? This question is meaningful. Okay? Yeah. Here, if you cannot imagine that, let me use a diagram to explain the situation. Yeah. Here, let's consider an arbitrary position somewhere in the middle. Okay? So to discuss if the element in this position to be used as the pivot, it's a good idea or the bad idea. Okay? So we want to see that. Yeah. How about this choice? Yeah. So let's try to explore a little bit. Yeah. First, we know this element is not in place in general, right? When you select arbitrary one in the middle, most likely it is not in place. Only very slim chance it happens to be in place. Okay, so that's our observation. Yeah. Then think about our goal. We want to make this pivot element in place at the end, right? At the end of the divide step. Okay. In order to do that, we need to move elements around, right? Yeah. Here, and we have to move elements in this array. Move around. When you move around, somewhere in the middle is the roadblock, right? You have to consider this position. Okay? Move to its left, move to its right. You have to do a lot of comparison, a lot of arrangement. It's not convenient. So that's why I call it a roadblock. Something right in the middle of the road block the flow from left to right, from right to left, block that flow. Okay? Roadblock. Right? Roadblock, it's not convenient. Right? Yeah. Can we find some special positions that won't be the roadblock? Do we have such special positions in the array that cannot be the roadblock? Yes, we have. Yeah. So this roadblock, we don't want to pick that. Okay? Not convenient. Yeah. Not convenient. Yeah. Then we try to find convenient locations. Okay? Yeah. The first one, leftmost element. It's not roadblock, right? Yeah. When you move around other elements, you do not need to touch the leftmost element, right? Yeah. Another special position, rightmost element. When you move around other elements, you do not need to touch the rightmost element, right? So only these two special elements are not the roadblock. Okay? The most convenient two positions. Leftmost, rightmost, that's the good positions. Good candidates. We can pick anyone, any of the two. Yeah. All right, so you can see. Yeah. Here, we know value-wise, no difference for all the elements, but position-wise, big difference. And we select either the first one or the last one. Okay? Yeah. But in our implementation, yeah, and in the textbook, so we like to pick the last one as the pivot element. Some other implementations, if you search on web, you may find the leftmost one is used as the pivot. Okay? Yeah. But the implementation, the general idea, essentially the same. Yeah. All right, so here, to be certain, so let us use the rightmost position as the pivot element. Yeah. Then, the remaining elements, we want to split them into A subarray and a B subarray with the properties. All the elements in A subarray must be less than or equal to P, and all elements in the right subarray must be greater than or equal to P. Okay? So that's what we would need to do. But how to do that? Next video. Okay? Next video, I will tell you that. All right, so let me stop here first. Yeah.